So in the previous in the previous class we have gone with a DQ concept. So DQ means double-ended queue. Okay, so which are the two ends of the queue? So one is the rear end, the other one is the front end. So there are two ends of the queue. Okay, so DQ means you can insert the element at the rear and front, and you can also delete the element from rear as well as front. Okay, so before you go with that one, kindly understand this particular concept. Okay, so come for this particular DQ. Okay, so see the diagram, what you have to do here. Okay, see this particular diagram. If you are inserting at the rear end, what should be done? So that means you are in, this is the rear end and this one is the front end. So keep in your mind, if you are going to insert at the rear end, what should be done? So you have to move the rear end from right to left. So you have to move one position from right to left because you are inserting at the right end. So if you are inserting at the right end, the rear pointer should be decremented. Okay, so rear pointer should be decremented and then you can place the item. So keep that one in your mind. When you insert an element at the rear end, so rear pointer which is pointing at 10 should come one position before. So one position before of 10 means one position left of 10. So rear pointer moving from 0th location to -1 location. So that we tell the rear is being decremented. Okay, so now you come for the insertion at the front. So if you are going with the insertion at the front, what is the case? So front is pointing to 70 and you are making one position to the right. So if you are inserting an element at the front end, what should be done? So you have to increment that particular element. So that's why if you are inserting an element at front end, you are going with a increment of the front end. So increment the front end and place the item. So similarly, if you are inserting an element at rear end, decrement the rear end and insert the item. So this is the concept you have to understand carefully. Okay, so come for the deletion. If you are deleting at the rear end, what should be done? If you are deleting at the rear end, move the pointer, rear end pointer from 10. Suppose if you are deleting at the rear end, that is element 10. So what should be done? The rear pointer should move to 15 and then you remove this particular 10. So rear pointer is pointing to where? It is pointing to element 10. So which is to be deleted. So now you are moving the rear pointer to, if you delete, where will be the rear pointer will point to? So rear pointer will point to element 15. So move the rear pointer from 10 to 15. Understood. So that means you are going to increment the rear pointer here. So move the rear pointer which is pointing at 10 to 15. So once you move the rear pointer from 10 to 15, then you delete the rear -1 element. So the rear is pointing now to which particular location? So rear is pointing now to 15. So this is rear. So this one is rear +1, rear +2. So if this one is 15 is rear, so what will be 10? 10 will be rear -1. So rear -1 is to be deleted. So that is the deletion at the rear end. Understood? So similarly, you come for the deletion at front end. So what you do for the deletion of front end? So for deletion of front end, so what is the front element you are having? It is 70. If you want to delete, so what should be done? Decrement the front. So if you delete, what will happen? So front, if you delete, the front will point to 60. So this one is at last location. This one is last but one location. So now front is to be decremented. So front end will point to 60. Now you remove Q of front. So Q of front minus will be done. So next Q of front is equal to element, you are going to remove that one. So this is the logic in double-ended queue. Are you getting? Are you getting the logic? So when you go to increment and when you go to decrement. So that will be the logic in insertion and deletion at both the ends. So are you getting the logic? Okay, so I will explain it once again. Kindly go through it clearly. Okay, so first you go for the inserting the element at the rear end. Okay, if you are inserting at the rear end, so where the element should come. So element is rear end is at 10, and if you want to insert, it should come after 10. So rear end should be, if you're moving from left to right, it is increment. If you are moving from right to left, it is decrement. So understand this one carefully. So now where you are inserting the element, you are inserting the element after 10. So this a space is to be created. So move the rear end to left. So move the rear end to left. So that means you are going with a decrementation. If you are inserting an element at the rear end, so what should be done? So move, decrement the rear end and place the element. So decrement the rear end and place the element. So similarly, you come for insertion at the front end. If you are inserting at the front end, where is the front end now? Front end is pointing at 70. So if you want to insert an element after 70, what should be done? So front is to be incremented. Keep in your mind, after 70. So before 10, decrement, after 70, increment. So keep that one in your mind. After 70, you are going for incrementing the front pointer and placing an element. So that is the second for insertion. Now you come for the deletion. So what happens if you are going for a delete? So now you see you are removing an element at the rear end. So which is the element you are removing? 10 is the element you are removing. Okay, so in order to remove this 10 element, so you have to move this. If you remove this 10 element, where the rear will point, so rear will point to 15. So before you remove the element, increment the rear to point to 15. So rear, which is pointing to 10, will increment and it will point to 15. So at that time you can remove this rear element. So while if you are removing the rear element, deleting the rear element, what should be done? So you have to increment the rear end and then you can delete this 10 element 10. Okay, suppose you see there you are going for a removing an element at front end. So if you are removing an element at front end, what will happen? So front end is pointing to 70. So front end is pointing to 70. So at that time you have to move back. So once you delete 70, where the front will point to? So front will point to 60. So now it is at 70 and it should come to 60. So what you will do? So you are coming one back. So before means decrement. So you are going to decrement the element and then you remove this particular. Decrement the pointer. So when you decrement the pointer, it will point to 60. At that time, you are removing this element. Understood? Now you got understood? Now you got understood? Any doubts? Any doubts you have? Okay, so now you have seen, now you go with the insertion. So come for the insertion, just you first, all these are checking for queue full. So I've already told in Dequeue, half of the part will be considered as front end and half of the part will be considered for rear end. So, okay, so for that, if front double equals max by 2, that is up to max means total number of elements of the queue. So total number of elements are 100. So front end will take 50 elements and rear part will go with 50 elements. So if front double equals 50, that means max by 2, then we consider it as queue full. So if not, what you will do, you are inserting an element. So if you want to insert at the front end, so end means front end. If you want to insert the element at front end, what you will do? So you are inserting an element after 70. So what should be done? Front is to be incremented and element is to be placed. So see here, front is being incremented here and element is being placed here. Okay. So again, if you want to continue, you can have A is equal to get char. So that means if A double equals 5, again execute. If A double equals n, so it will come out. So this is insertion at the end. Similarly, you go with insertion at the start. Start means at the rear end. So if you are inserting an element at rear end, what should be done? So rear end should come one place left. So this is rear plus 1, rear plus 2. But if you going out, it will be rear minus 1. So rear will come one position on left. So that's why we take it as rear minus 1. So rear is 10. So 15 is rear plus 1, 20 is rear plus 2. So for that, we take it as rear minus 1. So rear minus 1, that means you are inserting an element at the rear end. So that's why we take it here. We see rear is equal to rear minus 1. Why you decrement? Because you have to place an element on left. So next you read Q of rear is equal to token. Token is nothing but an element what you write. Okay. This is a insertion at rear end. So similarly, you come for the delete. So if you are going for deletion at the rear end, so deletion at the rear end means what is the element you delete? 10. So if you want to remove this element 10, what should be done? Rear end should point to 15. That means rear is to be incremented. Rear is to be incremented and then you remove rear minus 1. So see here. So rear is to be incremented so that it will point to element 15 now. So now rear minus 1 is been removed. So this, so rear, what is as you increment rear, so rear will point to element 15. So I have already told you rear will point to element 15 and rear minus 1 will point to element 10. So you should go through the scenario there. So where the rear is incremented, it will point to 15 and rear minus 1 is 10, that will be removed. Similarly, you come for the front end. So coming for the front end, what you will do? So for first, front is to be decremented because you are removing the element 70. So front end should point to 60. So first decrement the front end and then you remove this element 70. So that's why I am taking here front minus minus means you are decrementing the front end. Next you assign Q of front and make it null. So make it null on that particular element. Okay. So finally you have display. So you start from their end and you finish with front end, you print all the contents of the queue. Okay. So now you come for the main program. So in main program, now you are going with two choices. So two types of Dequeue. So input restricted and output restricted. Okay. So input restricted and output restricted, you have to see. So if input is restricted means first one you have insert. So you have to enter the choice. So see, very important here. So if it is deletion from end, so what are all the choices you will be having? So I will tell you there are two choices. First one is input restricted Dequeue, output restricted Dequeue. Okay. So you will be entering one particular choice. So case 1. So case 1 means it is input restricted Dequeue. So if it is input restricted, what will happen? So you can insert, delete from end, delete from beginning. Two choices you will be having. Okay. So delete from end and delete from beginning. So delete from end means what? Rear end. So beginning means what? Front end. So keep that one in your mind. So do enter the choice. So case 1 insert end, case 2 delete. So similarly you have all the display function. So this is for input restricted queue. Similarly output restricted. So output restricted means insert at the end. So that means insert at end means, so here it is insert from the beginning, insert from start. So keep this one in your mind. It is insert from start. So this one is insert from end. So input restricted means insert from start. So insert from start means, so in start means rear end. Okay. So this one is insert at rear end, delete from rear end, delete from both rear end. Okay. Input restricted, from where the input will come. Input will come from the rear end. So output will come at the front end. So input restricted means, so first one you will get insert rear. So delete from end means you will get delete rear. Insert from beginning means, sorry, insert from end means, so it will be delete front. Okay. So start means rear end rear end. Okay. Keep that one in your mind. So delete from beginning means delete front. So this is the case. So come for here, delete from end. So it will be insert front. So insert at the beginning means, so it is insert insert rear and delete the element. So delete the element means delete from rear. So this is the cases you will be having. So first choice is for insert end. So you have to use these two columns. So first one insert end, insert start, delete end. So then you write the entire program. So this is the program for Dequeue. Okay. So come for this is the execution part. So in this particular program, just you will call the functions. No, nothing is there. So you are going to call the functions, and this will be the execution part. So, this you can see. So first one input and output restricted. I have entered for input restricted. So enter the token 23. Again you have gone with 99 and queue elements it will show you. So do you want to insert? If you give no, it will show you the entire contents. So see here, so every time if you are inserting, there is a display function. If you are deleting, there is a display function. If you are deleting from the start end, there is a display. So each and everything you will be having the display function here. Understood? So now you come for the next thing. So next very important concept. So now you got understood the all the four types, right? Four types of insert rear, insert front, delete rear, delete front. Everyone got understood that one? Yes, tell me. So this is the attendance link. You can answer your attendance now. Yes, did you understand all the four types? Kindly reply. Shy people, kindly reply. Okay, next in now we will go with the last type of queue. So last type of queue is priority queue. Okay, so what is a priority queue? Okay, that we shall see. It is a queue but different from normal queue. Normal queue means what you have gone with a linear queue. Okay, it is different from normal queue because instead of being a first in first out, values come out in order by priority. It is abstract data type that captures the idea of container whose elements have priorities attached to them. Okay, jobs are scheduled in queue based on their priority number. In general, a job with least priority number will have highest priority, and a job with higher priority is dequeued before a job with a low priority. So here it will be scheduled on first come first serve basis. Okay, so NQ means insertion. So insert all the elements onto the queue. This is the queue. Okay, so you will be inserting all the elements, sort the jobs based on priority, and DQ means deleting the elements from the queue. So now you go with this particular thing. Okay, so now you see, so this is the priority queue ADT and structure. Okay, so under this now you see abstract for priority queue, you have to like this. So abstract data type, how you give, it is in the form of a structure. So structure, what is a structure? Structure is a data type. So struct is a keyword which contains a group of elements of different data types. Group of elements of different data types. So now you see here inside the queue. Okay. So inside the queue, so now I'm going with name and priority. So name and priority and jobs of 5. Okay, so job of name, job name and its priority. So similarly, how many jobs you are having? Job of 0, job of 1, job of 2, job of 3, job of 4. So as it is array of structures, so you will range from job of 0 to job of 4. So now you see job of 0 dot name is equal to help. Okay, it will be the first one to go. So now the first one you are inserting from this end. Okay, so help with priority 3, study, you see. So for study, what you have given, so it is 4. Okay, so for study, it is not 3, I have given it as 4. Now you see eat, I have gone with a 2, and for sleep, I have gone with a 1 and play. So before processing the jobs, so before processing the jobs based on priority, so you will be placing all the elements one after the other. So first comes help, next comes study, next comes eat, and finally sleep and play. Okay, so before processing job or items are scheduled, so after processing, before processing, now you see, this is the case. So after processing, so which one is giving a higher priority means the first one. So first one you go with sleep, then you go with second one is eat, and next you have play. So in that, which is the first inserted one, you have to see, because when you have the priority value same, you go with the first one. So first one inserted is eat and last one inserted is play. So on that two, which is the first one inserted? Eat. So eat will comes first, play will comes next, and finally the help, and finally fourth one is study. So this is the priority queue concept. So come for the implementation. So this is the implementation of priority queue. So what you will do for the implementation? So this is the very important program you have to go through. So priority queue implementation. So you have two programs on that. Okay, so first one is you are storing all this is adding the elements, and this one will go for deleting the elements. Okay, so first initialize the queue. So first you will start with a priority queue. Kindly understand, I will tell you. So it is very, very easy. Okay, so how you can easily write, it is very, very easy if you consider the bubble sort technique. So do all remember bubble sort technique? So all remember bubble sort, right? So if you remember, just you are shifting the elements from left to right, depending on the priority. So do all remember the bubble sort, then it is very, very easy to understand. So you can easily understand this particular thing here. So what you do when the first element is greater than the second element, so you are going with a sorting technique. So that one we call it as a bubble sort technique. If the first element is greater than second element, so here also you see you will get, so yes, the first element is 3. So second element is 4, but third element is 2. So if you want to swap, so what you will do? It will come here, elf will go in place of it. So that is the implementation that we will see in here. So first you take a priority queue. So initially front and rear both will be at no elements are there, means they will point at one location. So front and rear will be -1. Okay. So keep on inserting all the elements. I equals 0, I less than max, I plus plus. So how many elements are there? 5 elements are there. You are placing all the 5 elements. So copy d of I dot job slash 0 and d of I dot PR number as 0. So here we have taken the data. So first one is job of 10 and next one is PR number, that is priority number. So first initially it will be slash 0, no jobs will be there. So it copy d of I dot job, it will be slash 0. So all the boxes it will be kept slash 0 and priority as 0. So now you have to add each and every elements. So if you want to add each and every elements, what you will do? So first you will check for queue is full or not. So how you check for queue is full or not? If rear double equals max or max -1, so queue is full. Okay. If not, what you will do? You will increment the rear and place d of rear is equal to dt. What is this dt? It is a struct. Okay. So first initially, if front is double equals -1, front is equal to 0. Suppose now you start from here. So I is equal to front. So this is the concept of bubble sort. So for loop, what you take, it is bubble sort technique. It is bubble sort loop. First in bubble sort, first you will place I is equal to 0. I is equal to 0 means that 0 is been assigned to where? Front. So I is equal to front, I less than rear, I plus plus. So similarly, j is equal to, it will start from next position. J is equal to I plus 1, j less than rear, j plus plus. If d of I dot PRNO is greater than d of j dot PRNO, then you swap the elements. So this one is the code for swap the element. So this is, that is you are using the swap using temp variable. Understood? So similarly, if you are going with a delete, first you check with what? -1. That means queue is empty. If not, what you will do? T is equal to, so T is equal to D of friend, D of friend is equal to T. So this, or you go with a friend plus plus. Okay, so this is the data what you are going for the deletion. Okay, so now this is the data delete. Understanding? So finally you come with a main program. So coming for the main program, so first you have to go with a PQ, enter job description and its priority. So lower the priority, higher the priority. Okay, so first you will read all the elements, that is dt.job, dt.prno. So now you process all the elements. So process job, that will tell you like this. Okay, so this is the another program that we will see. Okay, so it takes more time. So this is the element program what we have taken for the priority queue. So just rather than going for the program, you can go with the two functions. So which are very important, this add function and the other one is data delete function. These two are very, very important from the exam. Okay, so this is the implementation. So this is up to priority queue. So what you do for insertion, what you do, so if you insert, you should sort according to priority. So how you sort, this is the front end, I is equal to front, I less than rear end and I plus plus, and next j is equal to front plus 1 and less than rear end. So if this one is greater than this one, what you will do? Swap two elements. So consider study and 8. So this one is at lesser, this one is at 4 is greater than 2. So you have to swap. So swap the elements using bubble sort technique. So this is the bubble sort technique what you have taken. So now for that, in order to place the bubble sort technique, what you will do? So you will be there at, this one is temp. Temp is equal to a of I. So next you will place, you will move all the elements to temp. Next you move it to steady place and steady to it place. So that is the priority queue implementation that you have gone with a bubble sort loops. So this is I is equal to friend, j is equal to I plus 1. PR number means priority number. If priority number is greater than the second one, then you swap the elements. Swap the elements using temporary variable. Similarly, you go with a delete. So if friend double equals -1 means queue is empty. If not, now you go with a d of friend. D of friend is equal to t. Now you remove, if friend is double equals rare, so that means it is no elements. So it will tell no element. So when no element is there, you will get front is equal to rear is equal to -1, else front plus plus. So this is up to the priority queue concept. Understood? So for this, it is up to this particular thing. Understood? So kindly go through the video, you learn the video in the YouTube, there you can easily understand. Yes, replay. Okay, this is up to today's class. So remaining thing we shall see, this is up to priority queues. So only one topic is left. So that we will see in the tomorrow's class. Okay. Okay. Thank you all.